I think we can get started. So welcome everyone to this week's office hours, where our topic is data is key to prior authorization success, where we're joined by Infinx's Chief Data Scientist, Natalia. Hey, Natalia, happy to have you on.
Hey, Alkirch. Yeah, thanks for inviting me to join.
Absolutely. And we're very excited to talk to everyone today about really the value of data in key patient access functions and none being more prominent than prior authorization. So having said that, I think let's get started. The first question I have for you, Natalia, is that within the prior authorization process, what information is really needed by the payers, right? And where's this data coming from?
Yeah, sure. So the data for prior authorization, it includes information about the patient, the procedure that is to be performed, and the provider or facility at a minimum. Now, some of this information may be necessary to ensure member eligibility, but other parts of the information and the data are required to ensure medical necessity. And at a minimum, they'll need the patient's insurance details, what procedure will be performed and where, and possibly diagnosis. Now, all of these types of data are considered structured data. That means that we can write it in a tabular form and that the values come from some standard set, such as plan numbers, NPIs, CPT codes, or ICD codes. Now, this may be enough to determine that a procedure does or does not require prior authorization. But in the case that prior authorization is required, then we will need additional data, since the medical necessity criteria will need to be met. So this is where the clinical documentation comes in. And this is a source of very valuable data that is difficult to extract. So the payer or the benefits manager may verify that the medical necessity criteria are met by asking a series of clinical questions or requesting that the clinical documentation be submitted to be reviewed by them. So this clinical documentation, it comes from the ordering provider, and it may be available in the order or referral form, but more likely than not, it's going to be part of the EHR and a lot of the visit notes. So when clinical questions are asked during this prior authorization process, the answers to these questions are found by interpreting this documentation. So again, patient chart or visit notes. And if you don't have that information and that data available, then you may need to, you may find yourself in a situation where you're going back and forth between the payer and the ordering provider to obtain the answers that you need to obtain that prior authorization. Now, previously I mentioned structured data. That's the CPT codes, plan numbers, and such. Clinical notes are considered unstructured data. And this is data that require in this case, it's text data, and it requires a human to read it, to interpret it, or on the computer side, it would require some natural language processing algorithms to be implemented in order to get that data out of the text. Now, you also asked, where is this data available? So some of the data may be available in scheduling systems. A lot of it would be available in the EHRs or order forms. And then prior auth platforms would also be storing some of this data as well.
Great. So, you mentioned unstructured data for a second, and, that manifests itself in the form of clinical notes. So what are the challenges really in obtaining that type of information?
Yeah, so when we get clinical notes, and when we say unstructured data is more than just the notes, right? So the documentation that would need to be submitted might be found in different forms in the EHR or in the patient file. And so we may have some lists, such as medication lists. We may be finding some tabular data, perhaps some previous lab results. And you mentioned specifically the clinical notes. So these would be the free text fields where we just have a paragraph written out. Now, these are the most challenging to really understand because parsing text into meaningful data, that is quite a bit of a challenge. So for example, natural language processing, NLP, and I'll go into this in a little bit. But there are different techniques to extract data from different types of fields, but the medical domain presents some additional challenges. So in clinical notes, we may find many ways that certain symptoms or diseases are stated. Abbreviations can have multiple meanings. And so when we look at this type of document, keyword search perhaps wouldn't be very helpful. So that's where we need these NLP models where we can identify the key concepts in this clinical text, symptoms, diagnoses, procedures. And just to explain what NLP is, it stands for natural language processing. I know you're quite familiar with this, but it draws on techniques from linguistics and computer science. So we're thinking algorithms in order to understand and extract information from text. Just getting a little bit more technical, we have some NLP models called entity linking models that can take the text, the diagnoses that are found, the procedures, and then link those to some standard ontology. This can be SNOMED CT codes, ICD-10 codes, CPT codes, RX norm codes. Exist many medical ontologies. And so an NLP model built and run through medical notes, that the model is capable of identifying symptoms and diseases, and say it's linked to or has an entity linking component to one of these ontologies. That model would be able to identify that, for example, neck pain, cervical pain, cervicalgia, neck ache, painful neck, that these are all the same concept. So now we're no longer dealing with words when we're talking about medical text, we're dealing with concepts. Now, going beyond identifying concepts and perhaps linking them, in order to extract real data from this clinical text, we may need some information such as the length of some prior treatment. And a payer may be asking, has the patient has physical therapy and for how long before approving an MRI? So that kind of information needs to be extracted from the clinical text. And it is not, or there's many different ways of writing this type of information. Or perhaps certain procedures may require a patient have a specific family history of a disease. So now we don't only need to know that the disease is present in the clinical text, but that it is in relation to someone other than the patient. And so these are just some of the challenges. There are many more with extracting data from these clinical notes.
Great. So let's shift our focus a little bit into the actual process of prior authorization. And I know a lot of focus is given to the process of initiating a request and waiting to get that information from the payer, wondering whether it'll be authorized or not. But I think an equally important part is even knowing what requires an authorization or not, right? So can you talk a little bit more about the role and value of data in even determining what requires an authorization or not?
Mm-hmm. Yeah, so as you just mentioned, some procedures don't even require prior auth. Now, it would be great if payers or benefits managers just made these lists available to all providers, and then that would make things a lot more simple. But that's not the case. These lists are not readily available. So now experienced prior auth specialists would probably have an idea of some of the procedures that don't require prior authorization, just based on their specialty and their experience with whatever payers they tend to deal with. However, the determination of whether the procedure requires prior auth or not will be dependent on several factors. And so while anecdotally one might know certain procedures or payers that often do not require prior auth, the human brain just isn't capable of keeping track of all of the combinations of payers, benefit managers, procedures, and all the historical outcomes that a practice has seen. So that's where data mining and machine learning can really help. So historical prior authorization data and collecting that and analyzing it will allow us to mine complex patterns to understand what consistently results, which patterns consistently result in a determination of not requiring prior authorization for a given request or for a given procedure, payer, and so on. Now, when we look at data mining and keeping data. And of course, my mind just goes to what else can we do with this data that we're collecting? We don't have to just think about what will require prior authorization or not. If we are storing this type of data, we could understand the patterns of historical data. So this is all objective data to understand what is frequently approved or denied. And now we're looking at combinations of CPT and ICD codes. Again, not something that like a human brain can really keep track of in a very reliable manner. So we can go further and talk about more complex models that could even go into clinical notes and extract information from there to determine not whether prior authorization would be required, but whether the request is likely to be approved or denied.
Sounds good. Thank you for that, Natalia. So we've spoken about determining whether an authorization is required or not. I think let's look at chronologically the next step here. Once you know an authorization is required, how do providers know what it is that they need to submit that will get them their authorization? What kind of information is required to actually initiate the request and meet those payer guidelines? And just a quick thing before Natalia answers, we're taking questions in the Q&A, everyone. So if you can just type your questions in right there, and I will post them.
Yeah, so you mentioned prior auth guidelines, and when thinking about what requirements needs to be met, that knowing what prior auth guideline to use is the first challenge that a provider might face. So in order to understand requirements, you first have to find them. And for this, you would need to understand, is your request going to be processed by a benefits manager? Is it going to be processed by the payer directly? Can you source now prior auth guidelines from all the payers and benefit managers that you need, as well as keeping up to date with the guidelines, since these are updated, maybe not significantly, but usually updated at least yearly or perhaps quarterly. I've even seen 30 days difference between different versions of guidelines. So providers need to keep up with the guidelines, and then they'll need to interpret them. So you have your list of guidelines, you're able to identify which one specifically applies to this patient that is trying to be scheduled. Now we have the guideline. These guidelines are written in free text. They are not a list of rules that is just a table that a computer can then go and find those exact values in a patient chart. So the provider needs to understand what is required in this guideline, and does the patient meet these requirements for the prior auth to be approved? So they're pairing up the patient's clinical information and the correct guideline, making sure they meet all the criteria, and then they can be fairly confident that their request will be approved. Now, once submitting the prior auth request, some benefit managers might just present a list of questions that need to be answered. This is one way of parsing certain guidelines. And so the provider has a more direct way of looking for certain criteria in their patient's clinical information. However, most procedures will not have such question lists to be answered. And even then, you need to make sure that the answers are coming from that patient's information in case the clinical information is requested later on. So in addition to identifying the correct guideline to be used, interpreting the guideline, pairing it up to the patient's clinical information to ensure the requirements are met. Now, providers will also need to understand which combinations of codes are likely to be approved or denied. And again, experienced prior authorization specialists will just anecdotally note that if I have 5 ICD codes and this one CPT code, this is the ICD code that makes the most sense for this prior auth request. But unless the provider has been mining this type of historical data, it is a challenge to know which codes in your patient's clinical text and their chart should be submitted for likely approval.
Got it, Natalia. So I think at least the last question I have for you before we can get to some of the attendees' questions is, I think it would be good to close on how you see, the future of prior authorization and patient access unravel itself within the realms of the applications of AI and machine learning, and what's the role of, say, clinical NLP in impacting that vision.
Yeah, so we've covered a few of the challenges in prior authorization and how like maybe extracting data and text through using NLP tools can help. So just starting off with, before getting to NLP, just to recap, we can use historical data to understand if an auth will be required in the first place. And we can also use historical data to identify some combinations of codes or perhaps of features in requests that are likely to have, or that would result in a request likely being approved or denied. Now, if we go to NLP, now there's a lot more that can be done, especially with that clinical information. Now, NLP is a field that is not stagnant at all. It is rapidly growing. And especially in the healthcare side, we are still seeing new developments. And as we have new technological developments, we'll be able to do even more with this clinical text. But this is key really in dealing with prior auth guidelines and their clinical documentation that's required. So from a vision point of view, can we get to the point where we have a particular patient and prior auth request? Now, can we use NLP to identify the correct prior authorization guideline and all of the requirements in that guideline? NLP could additionally then guide the decision of whether the patient needs these requirements for prior auth approval, and it could also try to identify any gaps in the documentation. Aside from extracting all of this information, which is quite challenging, if the models are finding multiple ICD codes in the clinical text or in the chart, then additional modeling can then be used. So we're using a combination of NLP and non-NLP techniques to identify which of these ICD codes would most likely return an authorization approval. So then that kind of guides the decision of what to have as your primary diagnosis. Now, so there are many challenges to implementing this type of model. This could all be done at the point of scheduling. And that's, I think, a huge benefit, because then you would avoid time delays that can occur when a payer requires additional information for a prior auth request, and that back and forth between the provider and payer, and just know with confidence that you are going to get an approval.
Sounds good. I think there's a couple of questions, so let's get to them. I think there's a question that asks about predetermination, Natalia. So I think you spoke about prior authorization and predicting whether an authorization is required or not. Do you have any insight into if the process would work similarly in determining predetermination requirements?
Yeah, so I'm not as familiar with the requirements for predetermination as for those for prior authorization. But if we understand what kind of data goes into determining whether predetermination is required or not, then all of this that I've mentioned builds on existing technology or on developing technology, perhaps, for some of it. But we have algorithms that are able to mine these complex patterns. That is something that could be applied to different types of decisions, as long as we have the data for it. So a key there would be to just have the historical data and a sense of what goes into that predetermination.
Yeah, I agree with that. And there's one more question which asks, the person says, I would like to know how to explain the value of data collection to others who are not experts in the area. What are some points that could be made?
But I think an important thing with having your data collected is that is a form of evidence. So you may hear that something happens very frequently, but perhaps it's because whoever's reporting that is just really paying attention to that one issue. Like, as humans, we're just not able to really calculate percentages of very high number occurrences or situations. In addition, we can't really explain specifically, or complex patterns, specifically what procedure would require prior authorization at a very, like, going into that pattern. So we can do an analysis, like, let's say that we're getting 100 requests in a day for this one procedure, then this many got approved or this many required prior authorization or not, but it's not clear what really caused that decision. So unless everything does not require an authorization or everything gets approved, you don't really know why. So if you start collecting this historical data, it just allows the computer to really form these patterns and just provide you so much more information that could then be used in more complex algorithms for making certain predictions or extracting information from text itself. But in a sense, data allows us to do a lot that the human brain is just not capable of doing. And it is also a very reliable source. So if you say, why did you make this decision? Then oftentimes you can go back to, oh, well, this has occurred 100 times in the past or 1,000 times in the past. And you can just, you can also quantify how likely certain outcomes are. And I mean, being a data scientist, I think data is really just an invaluable resource, but for the most part, it gives you an objective answer to many questions.
And, Natalia answered that very well from a technical point of view. I'll just provide my point of view on that as well. When you're, I think, really trying to talk to someone who's not as data savvy or quote unquote expert in this area, I think you have to just first tie it all to value that you're trying to gain out of any project or initiative that you're trying to do for your practice, right? If you're trying to improve processes, optimize, let's say, scheduling, or automate certain, resources that, are taking time or costing you a little bit more than they should be, and you do that through automation or predictive insights or analytics. These are really the three use cases here, right? I think all of them, as Natalia has outlined throughout this talk, really require clean data to give you the best bang for your buck in terms of really automating a process the right way, or to get the right predictive insight, or to tell you really what's going on within your business. So I think as long as you can tie it to the value you want to gain out of it, I think that is the right approach there. So I don't think we have any other questions. Let me just have a look at this. There's one last question. I think someone joined the meeting late. They're asking, Natalia, you'll be happy to answer this question. What is NLP?
Okay. Yeah, so sorry if you entered late, then a lot of the later part of the talk was focused on that. And NLP stands for Natural Language Processing. And it's like a branch of computer science and linguistics that allows to extract information from text. And actually, NLP exists in our everyday life. Any sort of text correction, any sort of text suggestion in our phones, all of that is due to NLP. Google searches, the way that they return results, all of that is NLP. Now, NLP in healthcare, and I covered some of these earlier, does have additional challenges. So then we focus on what's called clinical NLP and those techniques and how they can be used for prior authorization.
All right. Sounds good. Thank you so much, Natalia, for your time. Thank you, everyone, for attending. I hope you gained something out of this session. And, again, if you have any follow-ups or you would like to reach out to Natalia for anything, feel free to reach out to us at Infinx. You can find our contact information at infinix.com. So yeah, everyone, thank you again. Have a great rest of your day. And Natalia, have a great one. I'll talk to you later.
Thank you.
Thank you.
Thanks
Bye.
all.